Hello friends, today we are going to discuss about PN junction diode. PN junction diode. Here diode is nothing but which has got the two terminals. One is a positive terminal, other is a negative terminal. Then how we are getting a diode? So a diode is formed by joining together a P-type material with N-type material. Okay. So whenever we join a P-type material with N-type material, then it leads to a PN junction diode. It leads to a PN junction diode. Then coming to this p-type and n-type, here p-type material nothing but it is obtained by introducing the trivalent impurities to the pure semiconductor is called as p-type, and n-type nothing but by introducing pentavalent impurities to the intrinsic semiconductor leads to a n-type semiconductor. So now we are going to see what happens. Here we are going to check what happens if I combine this p-type material with n-type material. And here it comes to the here the majority. Here we have two concepts. One is the majority carrier, other is the minority carriers, other is the minority charge carriers. So these are considered as the charge carriers. These are considered as what? Charge carriers. That means we are saying that the current is flowing. What is the definition of current? It is nothing but the rate of change of so here the definition of current is given by I is equals to dq by dt, nothing but the rate of change of charge carriers. The rate of change of charge carriers with respect to time is nothing but current, isn't it? Here the charge carriers could be either electrons or holes. Electrons nothing but negatively charged and holes nothing but a positively charged. Is it clear? So these two combinedly called majority and these two combinedly called as a charge carrier. So in p-type, what are the majority carriers we have? In p-type, the majority carriers are holes and minority carriers are also there. Minority carriers nothing but electrons. In n-type, the majority carriers are electrons and the minority carriers are holes. So let us draw this diagram. Here we have p-type, here we have n-type. Okay. So in p-type we have what? Holes. Holes nothing but that means the vacancy of electron. Okay, the vacant electron is called as holes. The vacant electron is called as holes. That means it has a tendency to capture or to get an additional electron. So once it receives the electron, then it becomes what? A negative ion. It becomes what? A negative ion. So along with the negative ions, it also has what? Holes. It also has what? Holes. Okay, it also has what? Holes. And similarly in the n-type material, the majority carriers are what? Electrons. The majority carriers are what? Electrons. And here n-type nothing but it has excess electrons. It has so it has a capability to lose that excess electron. Once it loses that excess electron, then it becomes what? A positive ion. So along with this positive ion, it also has got a freely available electrons with it. Okay, it has a negative, it has what? Electrons. So in p-type, the majority carriers are what? Holes, and in n-type, the majority carriers are electrons. And similarly, the minority carriers in p-type is electrons, the minority carriers in n-type is holes. As we have already studied that as it is a p-type material, n-type material which has got opposite majority carriers, here it is a holes, here it is electrons. So these two has got opposite polarities with each other. Then what happens once we join these together, then the opposite charges likely to attract each other, isn't it? Opposite charges they attracts each other. Then this electron which is present nearest to the junction, and it starts attracting towards this hole and diffuses from one side to the other side, and becomes neutral, isn't it? So similarly, this particular electron, it gets combined with this hole and becomes neutral. It also combines with this hole and becomes neutral. So likewise, what happens? Slowly all the majority carriers in the n-type, they start diffusing to the other side, and similarly holes from the p-type, they start diffusing to the other side of the junction, and they start they gets recombined with this opposite polarity. So as a result, what happened? These ions, the tendency of the ions, the concentration of ions near the depletion region is increases. Okay, the concentration of the ion near the junction increases, and it forms just like a potential barrier. Just look at here it becomes a negative polarity, it becomes a positive polarity. Okay, it just forms like a electric field near the junction. It forms like a electric field near the junction. So this electric field or electric potential, it becomes like a wall. It becomes like a wall or barrier which is going to stop the further movement of the electrons and holes, which is going to stop the further movement of electrons and holes to diffuse from one side to the other side, as in the middle or in the near the junction it forms a electric field, and is also called as a potential barrier. So this is what happening whenever we are joining a p-type material with n-type material. Then the question is how we can overcome this barrier. Okay, then the question is how we can overcome this barrier. Just take the example, if two rooms are connected together by means of a wall. Okay, if two rooms, here we have two rooms which are combined together by means of a wall. Assume here the members from this room, they want to move towards this room. Okay, but in the middle it has a barrier, it has a wall. Then what happens, in order to move from this room to this room, they have to overcome this barrier, they have to overcome this wall, they have to break this wall. That means they must apply a external force. Okay, they must apply external force which breaks this wall. Okay, which breaks this barrier. Then only they can enter freely from this room to this room. Similarly here also, as it just like it is forming just like electric field or electric potential near the junction. So here we have to apply the external potential such that it must be greater than the potential of this barrier. It must be greater than the potential of this barrier. Okay, then what is the potential offered by this depletion region? What is the potential offered by this depletion region, or the electric field which is established near the junction means it is 0.7 volts. Okay, it is 0.7 volts if the particular PN junction diode is made up of silicon, and it is 0.3 volts if it is made up of germanium. Okay, so we have to check it with what material it is made up of. If it is made up of silicon, then we must apply the external external biasing such that it must be greater than or equals to 0.7 volt, and if it is made up of germanium, then it must be greater than or equals to 0.3 volts. So that's how here we are connecting what either forward bias or a reverse bias. Then the concept of forward biasing and reverse biasing comes into picture. So here we have what a PN junction diode. Here we have PN junction diode. So forward biasing means connecting the positive polarity of the battery to the p type and negative polarity of the battery to the n type leads to a forward biasing of the diode. As we know very well, here till this point the potential barrier is occupied. Here we have the ions which are immobile. Okay, they don't have the tendency to move from one side to the other side. Okay, simply they becomes what? Immobile. Okay, immobile means what? They don't have mobility or movement. Here we have the positive ions. And we know in p type the majority carriers are holes. In p type, and similarly the majority carriers in n type is electrons. So here what happens means, whenever you apply the forward bias or the forward voltage to it, since it is a positive polarity, and here also the majority carriers in p type is holes, then holes are also got the polarity of positive. Then this positive polarity and these holes, they start repelling each other. Okay, they repels with each other as they have the same polarity. Then because of repulsion, then these holes they try to move towards the junction and try to diffuse towards the junction. Okay, they try to diffuse towards the junction, but they are unable to move towards the junction due to this particular electric field or built-in potential which is established near the junction. That means here how long they can't diffuse from this p side to the n side, mean until and unless they break this barrier, they break the this potential barrier voltage. Then once the applied forward voltage is greater than or equals to 0.7 volts, then what happens means then slowly this width of the potential barrier decreases, as a result of which these majority carriers from p type they start diffusing towards the n type. And similarly here is it has got negative polarity. Here the electrons also have the negative charge, they both repel with each other and the electrons start diffusing towards the p side. So thereby the conduction starts as there is a movement of freely charged carriers available in that. Then the current starts flowing through the wire like this. As a result, what happens if you go for the characteristics of this p-n junction diode in forward bias? Characteristics nothing but what is a graph or plot which is drawn between the one physical parameter with respect to the other. Okay, one physical quantity with respect to the other. So usually, so this is the x-axis and y-axis. So usually we have to take on x-axis the independent parameter. Okay, independent physical quantity. So here the independent physical quantity out of voltage and current is voltage, because based on the voltage only current is varying. That's why we are taking on x-axis the independent parameter, there is voltage. On y-axis we are taking the dependent parameter because current is depending on the voltage, that's why we are taking on the y-axis. So if you plot the graph, essentially for 0 volt there should be no conduction. Here for 0.3 0.4 there won't be any conduction. Once it reaches the 0.7 then the current starts slowly conducting. Once it reaches the 0.7 suddenly there is a sharp rise in the current. So like this we get the forward characteristics of a diode. Okay, and the second thing we have what reverse biasing. Reverse biasing means what happens to the diode behavior, this p-n junction diode behavior whenever we connect a reverse polarity of the battery. Reverse polarity of the battery. So this is the p-n junction diode we have, and here already we have what this depletion region. We are connecting a reverse polarity of the battery, that is p type is connected to negative polarity, n type is connected to positive polarity. Then what happens here, we have the holes at the majority carriers and electrons at the majority carriers. Then here the polarity of the battery is negative, then these holes try to attract towards the negative polarity of the battery. Similarly the electrons, most of the electrons they try to attract towards the positive terminal of the battery. Okay, and already we have what the immobile charge carriers present with near the junction. Then the width of this depletion region, width of this immobile ions, they start increasing, isn't it? Because all the majority carriers get attracted towards the battery. Then the leftover is what, only the ions which are present here. Okay, the negative ions, concentration of the negative ions near the junction, similarly concentration of the positive ions in the junction increases. As a result the depletion width region becomes widen. So that means what, the built-in potential width is going to be increases. Once it increases, then what happens, the strength of this particular ions is more, and it stops the further movement of the charge carriers to flow from one side to the other side, due to which we get water, due to which we get the resultant current which is flowing through the diode in the reverse bias condition is approximately 0 or very negligible. Okay, ideally it is 0, but in practical ways it will be very negligible in terms of microamperes it will be there. And that microamperes current is also due to the movement of minority carriers, due to the minority carriers. Okay, that means we get only the small, if you go for the reverse bias characteristics, then we get only the small current in the reverse bias. That's how the behavior of a p-n junction diode and its operation will be explained by means of this VI characteristics. Thank you.